Right from the alkanes, the first type of reaction that we have for alkanes is combustion reaction, where you have CXHY plus X plus Y by 4 times of oxygen to give you X moles of CO2 plus Y by 2 moles of H2O. Any organic compound generally provides you this combustion reaction here. It could be any organic compound, alcohol, ethers, phenols, anything. If carbon is there, definitely it will undergo combustion reaction.
Yes, ma'am.
Now you can see this X moles of C is becoming X moles of CO2. So the number of moles of CO2 that you obtain after combustion corresponds to the moles of carbon in the organic compound. Similarly, you can see Y moles of hydrogen is getting converted into Y by 2 moles of water, right? So I can understand this water which is having hydrogen is only from this hydrogen here. So for example, if I say there are 6 moles of water is being produced, what do you understand here? That means Y by 2 value is 6. Then what is the value of Y here? 12. Then that means the number of moles of hydrogen is 12. This is from the combustion patterns of this hydrocarbons, alkanes. The second type of reaction for hydrocarbon, alkane, is free radical halogenation reaction. Free radical halogenation reaction. So I have CH4. I treated with chlorine in the presence of light, H nu. Where I can see it can give you CH3Cl, CH2Cl2, CHCl3, CCl4. The first step of the reaction is called as initiation reaction, where this chlorine molecule is getting homolytically cleaved and undergoing homolytic cleavage. What you synthesize here is 2 chlorine free radicals. And the next reaction is called as propagation reaction. Where I have methane, I am having CH4 here. So this chlorine Cl dot is coming for propagating it. Okay. So I have H3 and H and Cl dot is there. Okay. Now what happens here?
Yes, ma'am.
This undergoes an homolytic cleavage so that I get CH3 dot, H dot and Cl dot. Now this CH3 dot and the Cl dot can combine together to form CH3Cl. And that's how the reaction proceeds here. Now ma'am, why don't you think H dot and Cl dot is going to combine to form HCl? This will also happen, but this does not. This does not belong to the halogenation step. So they'll give you several steps. They're asking you which does not belong to halogenation step. This does not belong to halogenation step. So this further goes on and on so that you are going to get this different products here like CH3Cl, CH2Cl2, CHCl3, CCl4, etc. The last reaction is called as termination reaction. That means it is going to terminate it. No more free radicals are there. Zero free radical availability. And that is called termination. I can see Cl dot and Cl dot is there. They too can combine to form Cl2. H dot and Cl dot is there. They too can combine to form HCl. isn't it? This is called termination reaction. So these are the primary two types of reactions the hydrocarbons would undergo. Understood? So let me consider to this I'm giving chlorine in the presence of H nu. The moment you see chlorine in the presence of H nu, remember it is a free radical halogenation reaction. It would attack on the alkyl part only, not on the benzene, remember. So where will it attack? I have two spots here. I have one spot here, I have another spot here. Where will it attack? Now the attack will happen with respect to the free radical stability. Attack will happen with respect to the free radical stability. Consider I'm forming two types of free radicals here. One is like this, right? I'm creating free radical. Ma'am, how do I generate this free radical? This is bonded with hydrogen, like this. If this is undergoing a homolytic cleavage, this will form C dot CH3. This is one free radical. What is the other type of free radical it can generate? CH dot CH2 dot.
Yes, ma'am.
Now, among them, which is the
Uh,
most stable one? This is the most stable one because what you're seeing here is benzylic free radical.
uh,
This is more stable because we know the free radical stability is very similar to carbonium stability. So therefore, the chlorine must attack here. So therefore, what should be my product here? This will be my major product. CCl-CH3. This is major. Am I right?
yes, ma'am.
Right?
Yes, ma'am.
Yes. CH2, right? And what will be my minor product? This will be my minor product.
Yes, ma'am.
Right?
Mm.
So these are the fundamental two types of reactions the alkanes family will undergo. Okay. The next type of reaction is the majority of the type of the reactions with respect to alkenes and alkynes only. So when I have alkenes or alkynes, they are having this unsaturation here. That means double bond or a triple bond. So I'm having C double bond C, I'm having C triple bond C. So the C double bond C compounds, preferentially they are called as olefins. Oily liquids they are. So this is a sigma bond, this is a sigma bond, this is a sigma bond, and this is a pi bond, right? Similarly, this is a sigma, 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 two pi bonds are there. So qualitatively, they will be able to answer the unsaturation test. What test they are? Bayer's test with the potassium permanganate followed by chlorine water test or bromine water test, where the orange color liquid will become colorless. So these are the ones which should show you whether it is having the double bonds or the triple bonds here. Clear till this?
Yes, ma'am.
Now, generally, they'll give you some formula asking you to find out whether it is having a double bond, triple bond rings, etc. For that, we'll use DBE calculation, double bond equivalence calculation. It's given by many ways of there to calculate it. C plus 1 minus H by 2 minus X by 2 plus N by 2. C stands for number of carbon it is having. X stands for number of
Yes,
halogen it is
ma'am.
having. So if I find the
Huh.
dBe value is 1, it means it could have either one ring or one double bond. If the value is 2, I can understand either it could be a triple bond or two double bonds are there or two rings are there or one double bond and one ring is here. Like that I can understand.
Yes, ma'am.
Now moving for the double bonds or the alkenes or the alkynes reactivity. First reaction of alkenes that we are going to see is hydrogenation reaction. Where I just had hydrogen across the double bond or a triple bond in the presence of nickel, palladium, platinum, metal catalyst plus hydrogen in the presence of nickel or platinum or palladium that is going to form ethane here. So I can understand to cleave one double bond I need 1 mole of hydrogen. This is a double bond. To cleave this double bond I needed 1 mole of hydrogen. In case if I had a triple bond then I will need 2 moles of hydrogen here. That's it. The second reaction of the double bonds is hydration reaction, where we are going to add water across the double bond or a triple bond. So I am having CH3, CH, double bond CH2 plus H2O in the presence of H plus. Now which rule we will follow? We'll follow the Markovnikov rule, isn't it? We'll follow the Markovnikov rule here,
Yes, ma'am.
where the OH, the negative addentum, will get added to the more substituted carbon of the olefin. So what will be my product? CH3, CH, OH and the CH3.